So now we're going to talk about how we can solve rational inequalities. And we're going to use the same exact technique we used when we were solving polynomial inequalities. The only added difference is that when we solve a rational inequality, we need to take into consideration that values in the denominator is going to give us values that are undefined. And we want to include those on our sign chart. So whatever values of x makes the numerator equal to 0, those are going to be your x-intercepts. So my x-intercept is going to be -2 because that's the value of x that I would plug in to make the numerator 0. Whatever I would plug in for x that would make the denominator 0 is going to be our undefined values. So I'm going to be undefined at x equals 3. So when I make my sign chart, I'm going to, again, make sure you put it in order like you would on a number line. I want to put the smaller value to the left. I have -2 here and 3 here. Since -2 is a 0 or an x-intercept, I want to make sure I label that with 0 there above it. And then 3 is undefined, so I want to label that as undefined. And that way, when we go to write down our final answer, if we can use that information on how we labeled our graph to decide if we're going to include or not include any of those numbers. So now, just like before, I'm going to pick test points to plug in. So this was broken up into 3 intervals. I have this interval here, which was from -infinity up to -2. Then I have this interval here in between, which is -2 to +3. Then I have this interval here, which is from 3 to infinity. So I'm going to pick a test point on this interval right here. I'll pick, say, -3. If I pick -3 to plug in and test it, so I'm going to plug in -3 here and here, and for my x's. If I plug in -3, I'm going to get a positive number. Now I'm going to pick something on this interval right here from 2 to 3, or sorry, from -2 to 3. When I plug in, let's say I plug in 0 as my test point, I'm going to plug it into these 2 values of x right here. And when I do that, I'm going to get a negative number. And then I'm going to plug in a number bigger than 3 on this interval right here. Let's say we plug in 4. That is going to give me a positive number. So now I go back and look to see what the question says. I'm looking to see where this rational function is greater than 0. If it's greater than 0, we're looking for positive intervals. My positive intervals are here and here. I am not looking for where it's equal to 0, so I don't want to include any of my x-intercepts. So since I'm looking for intervals that are greater than 0, I'm going to choose this interval here, which would be from -infinity up to -2, not including my x-intercept because it's not including 0. Union, and then this interval here, since this is undefined at 3, I definitely don't want to include that. There's no value there. So I want to make sure I use parentheses with that one. So 3 to infinity. Okay, the next example is also a rational inequality. I want to find my x-intercepts. That's what makes my numerator 0, the values of x that make my numerator 0. So I'm going to have an x-intercept at -5. And the places that it's undefined is going to be the values of x that make the denominator 0. So I'm going to have a 3 and a -1. That's what makes the denominator 0. When I put these values on my sign chart, I have -5. Make sure you put them in order. Then -1 and 3. Put them in order from smallest to largest, left to right, just like on a number line. This breaks it up into 4 intervals. 1, 2, 3, 4. Now this point right here at -5 is a 0. It's an x-intercept. But at 3 and -1, it's undefined. So I want to make sure I label that so I know the difference. Okay, so I'm going to pick test points. When I plug in -6 for this interval right here, I'm going to plug in -6. That's going to give me a negative number. So I know that from -infinity up to -5, that's going to be below the x-axis. Now I'm going to pick something between -5 and -1. You can plug in anything you want as long as it's on that interval. I'll try -4. When I plug in -4, I get a positive number. Then I pick something between -1 and +3. I like to pick 0. So I'm going to plug in 0 for all my x's, and I'm going to get a negative number. And then my last interval is to pick something from 3 to infinity. So I'll pick 4. So I plug 4 in for all my x's, and I'll find that I get a positive interval. Now, keep in mind, the examples we've done so far, a lot of times it alternates positive, negative, positive, negative. It doesn't always do that, even though it does. A lot of times it does that. But please don't make that assumption. You should still check, because there are instances where you have 2 negative intervals in a row or 2 positive intervals in a row. Okay, now that we've made the sign chart, I'm going to go back and look at the question. This question is saying, where is this rational function less than or equal to 0? So I want to pick values on my sign chart where it's negative or it's equal to 0. The places that it's negative is this interval right here and this interval right here. It's also equal to 0 right here. Here's my x-intercept. So I want to make sure I include that -5. I do not want to include -1 or 3 because that's not where it's equal to 0, that's where it's undefined. And this is a perfect example of why it's important to label your sign chart on whether it's a 0 or if it's undefined. So my final answer is going to be from -infinity up to -5, including -5, union, and then open parentheses, -1 to 3. So I don't want to include -1 and 3 because that's where they're undefined, but I do want to include -5 because that's where it's equal to 0. And it's asking me for that. Where is it negative or equal to 0? Okay, next example, we have a rational function here, 6 over x minus 3 plus 1. But if you go back and look at the other examples we did, we need to make sure that we have 0 on one side, just like we have here, and just like we have up here. But it also needs to be written as one fraction, one term. That's what we have here. Right here, I have it written separately as 2 different terms. I have to combine those and write it as one fraction. I do have 0 over on this side, so we're good there. If you have it written where it's 2 terms, you have to combine it into one fraction. So I'm going to first combine this. I'm going to write +1 as x minus 3 over x minus 3. That way I have a common denominator and I can combine my fractions. So up top, I have 6 plus x minus 3 all over x minus 3 because I have a common denominator. Now, if I continue this up here, I can combine the 6 and the 3, and I have an x plus 3 over an x minus 3. And I'm looking to see where that's less than 0. So my x-intercepts, that's going to be the values of x that make the numerator 0, which would be -3. So that's a 0. I'm going to put a 0 up here. And then what makes the denominator 0, the values of x that make the denominator 0 is going to be where it's undefined. So that would be at x equals 3. So I'm going to label this as where it's undefined. Then I'm going to pick test points. When I pick test points, I'm going to pick something less than -3. Here are our 3 intervals. Everything less than -3, between -3 and +3, and greater than 3. When I pick test points, if I plug in -4, I'm going to get a positive interval here. If I pick something between -3 and 3, say 0 as my test point, and I plug in 0 for this x and this x, I'm going to get a negative number. And then if I pick something bigger than 3, say +4, I am going to get a positive number. Now, if I look back, it's saying, where is my function less than 0? So I'm not looking to see where x equal to 0. I'm looking for just where x less than 0. So I don't want to include my intercepts. And I obviously don't want to include the places that it's undefined. So this is my interval. And my final answer will be from -3 to 3. And again, I don't want to include -3 because this doesn't have an equal sign here to include the 0. And I don't want to include +3 because that's where it's undefined. Okay, last example. Again, I have 0 on this side, but I have 2 terms. So I have to combine them before I start finding my x-intercepts and my places, the values of x that makes this undefined. So I want to make a common denominator so I can combine these together. So for the first fraction, I'm going to multiply the top and the bottom by x plus 1. For the second fraction, since I want a common denominator, I'm going to multiply the top and the bottom by x plus 3. Now that, whoops, I forgot my x plus 1. Okay, now that I have a common denominator, I can combine them together, and at the same time, I'm going to distribute my 5 and my 4. So I have 5x plus 5 minus 4x minus 12 all over my common denominator, which is x plus 3, x plus 1. And that should be greater than or equal to 0. I made sure that I distributed my minus. This is subtracting everything up top here. So it's subtracting the 4 times x and it's subtracting the 4 times 3. So I want to make sure that I distribute that negative. Now, when I clean this up a little bit, I'm going to get x minus 7 over x plus 1 times x plus 3. And that's greater than or equal to 0. Because it's greater than or equal to 0, I want to make sure that I include my zeros or my x-intercepts in the final answer. So when I make my sign chart, I have my x-intercepts. The only one I have here, that's the values of x that makes the numerator 0. That would be 7. I'm going to put a 0 up here. And then I have 2 places that it's undefined. The values of x that make the bottom equal to 0 would be -3 and -1. This is where it's going to be undefined. I make sure I label that as well. Then I'm going to pick test points. So I'll pick -4 for this interval. When I pick -4, that's going to give me a negative interval. When I pick something between -3 and -1, that's going to give me a positive number when I plug that in. And if I pick something between -1 and 7, that's going to give me negative. And when I pick something greater than 7, let's say I pick 8, that will give me a positive interval. Okay, once I have my sign chart, then I'm going to go back and look at the question. The question is saying, where is this rational function greater than or equal to 0? So I want to look to see where it's positive and where it's equal to 0. Here's where it's equal to 0, and it's positive on this interval here and this interval here. So that's what I want to include in my answer when I write this out in interval notation. I do not want to include the -3 or the -1 because it's undefined at those values. So I want to make sure that I use parentheses for that interval. So between -3 and -1, I'm positive, but not including -3 and -1. Union. And then for this one, I do want to include 7 because x is 0. And then from 7 to positive infinity.